Well, so the next topic is expansion. What is expansion? Why? On doing what? Emni.
On absorbing energy.
Cano.
Cano because kinetic energy very
Dorka, right? So when see, it's a very simple thing. When you supply heat energy, हमने एक discuss करना, it increases the internal energy of its molecules. तो अगर internal energy of its molecule increase करता है, तो molecule का vibration ज़्यादा होगा, right? तो molecule का vibration अगर ज़्यादा होगा, तो उसको रखने के लिए ज़्यादा space चाहिए होगा. Very simple a question. Would you require a bigger place to build a classroom for 20 students or a playground for 20 students? Playground क्यों? बिल्कुल playground क्यों? वहाँ पर सब लोग खेलेंगे ना, तो खेलेंगे तो 20 आदमी के लिए 20 स्टूडेंट्स के लिए जगह बहुत ज़्यादा चाहिए होगा, समझ में आया? So इसलिए whenever you supply heat energy to any substance, it starts vibrating. The molecules of the substance starts vibrating with higher amplitude, and that's why they require more space to be kept. But with our naked eyes, we don't see that expansion. Why? Because the expansion इतना छोटा होता है. The expansion is so small now, 10 to the power minus 6, order of 10 to the power minus 6. Solid sector. For solids, it is of the order of 10 to the power minus 6. Liquids and gases expand much more than that of the solids. So that's why we don't see them in our naked eyes, everyday life. But they can be the cause of major accidents. Again, there are few major accidents that took place when we used to build bridges in the very early times. Why? Because when the bridges were started being constructed on the basis of metals. Previously, very old bridges were made up of wood. But when they found that metals are better, stronger objects, they started building bridges of metals. They found a very big difficulty. What difficulty? During summer, the bridges expands, and during winter, the bridges contracts. Railway tracks can do it. So that is why when they build bridges, they have to keep some space for this expansion to take place. Otherwise, the bridge will collapse. The same thing with the railway tracks. When you see the railway tracks, when one rail, that's the ending point, the starting point of the other rail, there is a small gap left between the two rails, and that is being joined with a fish plate. Okay, so why is that gap kept? Because during summer they expand and they need that allowance for expansion. So now what happens? The reason for expansion is known to us. So we need to analyze expansion for solids. First we are doing expansion in solids. Okay. Since solids do have their own shape and size, there are three different types of expansion for solids. Key expansion?
Cubical or
Linear. First will say linear expansion of solids. Now listen, when we are doing linear expansion of solids, एक छोटा सा question है. There is a small question. Say we have a rod of length L, initial length L, alright, and initial temperature be T1. Initial temperature T1 and final temperature is T2. Okay? And say the initial length is L1 and the final length is L2. Initial length is L1. Therefore, delta change in length is how much? Change in length is equal to delta L. Is given by delta L equal to L2 minus L1. Now tell me, what are the factors on which the change in length will depend? Change in length temperature के ऊपर डिपेंड करेगा. मतलब टेम्परेचर जितना ज़्यादा रेज करेंगे, लेंथ उतना ज़्यादा बढ़ेगा. It's a very simple thing. ফোর্স কোথায় দিচ্ছ তোমরা ফোর্স দিচ্ছ না
ম্যাটেরিয়াল
ম্যাটেরিয়ালের উপর ডিপেন্ড করবে কিন্তু আরেকটা জিনিসের উপর ডিপেন্ড করবে সেটা হচ্ছে इनिशियल लेंथ जितना लंबा होगा उसका एक्सपेंशन भी ज्यादा और इनिशियल लेंथ छोटा होगा तो एक्सपेंशन भी ऐसा क्यों
सर बेसिक मॉलिक्यूल की बात है बेसिक मॉलिक्यूल से बेसिक स्पेस होता है
हाँ राइट इट्स अ वेरी सिंपल थिंग जैसे मान लो if you have a queue of 5 person and another queue of 10 person and you ask everyone to stand one hand apart distance तो कौन सा queue ज्यादा लंबा हो जाएगा 10% वाला राइट बिकॉज़ वहां पर ज्यादा पर्सन है तो सब लोग एक एक दूसरी जगह में जाएंगे सो सिमिलरली जितना इनिशियल लेंथ लंबा होगा उसका एक्सपेंशन भी उतना ज्यादा so you can say that delta L is proportional to delta T what is delta T T2 minus T1 ठीक है and also ना क्योंकि वो तो टेम्परेचर कितना बढ़ा रहे हैं उसके ऊपर डिपेंड करेगा वो टाइम हम आधा घंटा में इंक्रीज किया या 5 घंटे में इंक्रीज किया उससे कोई फर्क नहीं पड़ेगा टाइम के ऊपर डिपेंड नहीं करेगा so delta T is the change in temperature so this change in length is proportional to change in temperature and initial length L1 समझ में आया हाँ सो अगर हम लोग प्रोपोर्शनल साइन हटाएंगे और इक्वल साइन लाएंगे तो हम लोग को क्या लगाना पड़ेगा एक कांस्टेंट तो यहाँ पर कांस्टेंट है अल्फा is called coefficient of linear expansion so you can write alpha is equal to delta L by delta T into L1 ठीक है so what will be the SI unit of coefficient of expansion Kelvin inverse डिग्री सेल्सियस इनवर्स या केल्विन इनवर्स कोई भी हां
इंफिनिटी को लगता है डेल्टा
अल्फा এটা তো এটা ইনফিনিটি নয় proportional ঠিক আছে this is proportional আর এটা হচ্ছে alpha coefficient of linear expansion হচ্ছে alpha is that clear for small changes alpha can be written as 1 by L dl dt 1 by L into dl dt ठीक है because this delta L will become dl this delta T will become dt and this L will remain out there so initial length or any instantaneous length can be written as 1 by L now the final length L2 वो क्या होगा देखो L2 यहाँ से ये वाला इक्वेशन से हम लोग L2 का वैल्यू क्या लिख सकते हैं हाँ L1 plus delta L2 right so it will be L1 plus now that is L1 plus delta L क्या निकाले हम लोग alpha delta T L1 right so that means L2 को हम लोग लिख सकते हैं L1 taken common 1 plus alpha delta ठीक है सो फाइनल लेंथ निकालने के लिए ये वाला फार्मूला यूज करेंगे कोएफिशिएंट ऑफ लीनियर एक्सपेंशन निकालने के लिए ये वाला फार्मूला यूज करेंगे और चेंज इन लेंथ यूज करने के लिए हम लोग ये वाला फार्मूला यूज करेंगे ऑलराइट फाइनल लेंथ The next topic is superficial expansion of solids. Now, superficial expansion of solids is just the same idea that it depends upon the initial surface area and depends upon the change in area, depends upon the change in temperature. So, say you consider any surface, any particular surface having an initial area S, S1 and final area, say initial surface area S1 at T1 temperature, final surface area S2 at T2 temperature. Therefore, change in area delta S is S2 minus S1 So they are saying delta S is directly proportional to S1 and delta T. So similarly, if you remove the proportionality sign over here, you get a constant. We write it beta S1 coefficient of superficial expansion. So all these coefficient of expansions, they are material dependent. Means if you are taking iron, the value will be different than that of copper. So now, so obviously beta का value निकालने जाएंगे. If you want to find out the value of beta, it will be S1 delta T. Beta equal to delta S by S1 into delta T. Okay. So SI unit is again per Kelvin. Because delta S will cancel, सिर्फ delta T यहाँ पर बचेगा. मतलब dimension में surface area का dimension बढ़ जाएगा, delta T बचेगा. Clear? Now, now if you want to find out the final surface area S2 is equal to, see S2 is equal to S1 plus delta T. S2 equal to S1 plus delta S, right? So S1 plus delta S माने क्या की? Beta S1 delta T. So of course you get S2 as S1 taken common 1 plus beta delta T. So if you want to find out the final surface area, use this one, right? And of course this is change in surface area. And why am I boxing up these equations? Because this will be the working equations, right? Working equations. And one important thing for small changes, beta can be written as 1 by S ds dt. Okay? S represents surface area, okay, not displacement. Acha, question number volume expansion of solids. So what? Again the same thing. We consider a volume of any object. So I took up a cube at least over here. Now say initial volume is V1 at temperature T1 and final volume is V2 at temperature T2. Alright? So change in volume, delta V is V2 minus V1. Now delta V is directly proportional to change in temperature and also directly proportional to initial volume. So if we remove the proportionality sign, bring an equality sign, delta V can be written as gamma delta T. Okay? So what is gamma? Gamma is the coefficient of volume expansion. Coefficient of volume expansion. Alright? কোনটা? এই গামাটা হচ্ছে কোএফিশিয়েন্ট অফ ভলিউম এক্সপ্যানশন। ওই একই জিনিস, দেখো কোনো নতুন ফেরে নেই। ওই লিনিয়ার এক্সপ্যানশন, সুপারফিশিয়াল এক্সপ্যানশন একই জিনিস, শুধু তার জায়গায় সারফেস এরিয়ার জায়গায় ভলিউম এসেছে। So therefore final volume V2 is equal to V2 টা কি হবে? delta V plus V1. So গামাটা লেখা হলো না। আচ্ছা এখানে ফার্স্টে লিখে নিই একটুখানি। Gamma is equal to delta V by V1 delta T. Okay? And for small changes, gamma can be written as 1 by V dV. Alright? So final volume V2 is equal to what? Final volume V2 is equal to V1 into 1. V1 plus delta V. That is V1 plus delta V is gamma V1 delta T. So you can take V1 common, 1 plus gamma delta T. This is the final volume. কি ভালো লাগছে?